Welcome back. So now we move to more information about the cluster analysis. Cluster analysis is also called data segmentation because we want to get similar group. It's a collection of the techniques that seek to group or segment a collection of objects, either observation or record, into subset or cluster, such that those within each cluster are more closely related to one another than objects assigned to different clusters. The object within cluster should exhibit a high amount of similarity, whereas those in different clusters will be dissimilar. So we find characteristics that is common to those within the same cluster. So cluster analysis method in practice involves something like hierarchical clustering. The data are not partitioned into a particular cluster in a single step. Instead, a series of partitions take place, which may run from a single cluster containing all objects to n cluster, each containing single object. So initially you look at them together. You now look for a way to divide and study again and divide, study again and divide. Then you may now find a way to aggregate and now get a specific group. So we can now do agglomerative clustering method by a series of fusion of the n objects into group. So after you have done division, you now see that there is one part of part B, maybe item n, that is similar to item M. You now group them together. Or divisive clustering method by separating n objects successfully into final groupings. So, okay, this one, they are together, but you still find a pattern that can separate them into two. Then you divide. Then they have become two groups. So you can divide further. Hierarchical clustering may be represented by a two-dimensional diagram called dendrogram, which illustrates the fusion and division made at each successful stage of analysis. So we see that cluster analysis is an in-depth activities. So scope of this data mining, we have data exploration and reduction. Identify group in which elements are in some ways similar. Classification, just to analyze data to predict how to classify a new element. Association, analyzing the database to identify natural association among variables and create rule for target marketing or buying recommendation. We can now do cause-effect modeling by developing an analytical model to describe relationship between metrics that drive business performance. This may involve things like regression analysis. Now, decision tree is another method that we've mentioned before. It consists of nodes and branches. So node is the point of decision, branches are the alternative that are useful approach to structuring decision problem that involve uncertainty. Nodes are points in time at which events take place. Decision node are node in which the decision takes place by choosing among several alternatives, usually denoted as square. Event node are node in which an event occurs that is not controlled by the decision maker, usually denoted as circle. Those of us that have done something in decision tree before, we relate with this. When we talk of classification methods seek to classify categorical outcome into one or two groups as said. For each record in a database, we have a categorical variable of interest and a number of additional predictors. For a given set of predictors, we would like to assign the best value to the group. When we do the measure, we calculate classification performance by finding the probability of making a miscalculation error and summarize the result in a classification matrix. We show the number of cases that were classified either correctly or incorrectly. So if you have table like below, where we have predicted classification and actual classification, you predicted something that somebody will not be a good loan customer, and it is, you are right. So you decide that this is true and it is actually true, so that's correct. You rejected somebody that will be a bad person, so that's also correct. But this one that you predicted 0 where it is 1, you predicted false where it is true, so that is an error. Then when you say it's true when it is false, it's also an error. So all diagonal elements are miscalculation. So diagonal elements are the one on this 23 and 25. So up diagonal is the 0 and 2. So probability of miscalculation here now is 2. out of the entire 50 when you add 23, 25, 0 and 2 together. So 0 plus 2 are the error part. So the error here is 0.04. So either you do it physically like this or computer is doing it. Those are the kind of calculation that go behind that determine whether your classification is good. So if you do a method of classification and you get this result, and you do another one and the error there here is about 5, and instead of 0.04 it become maybe 10%, you know that that one has higher miscalculation than the first one, and you cannot choose. So most of the method we have a way of checking whether they are good or bad so that we can decide. Thank you.